All right, next one. Example 4, 7 is greater than or equal to x minus 3. Again, we're going to isolate our variables, so we're going to do plus 3 on each side. We get 10 is greater than or equal to x. Now, we'd like to write it so that our variable is on the left. That's going to make it easier for us to understand how to graph it and put it in the proper form. So what we need to do now involves the symmetric property of inequalities. Basically going to swap sides. We're going to reverse it, but it's important that when we do that, we need to retain the relationship between the number and the variable. If you read it left to right, it says 10 is greater than or equal to x. So think about that. What are some numbers that 10 is greater than or equal to? Well, it's greater than 9, it's greater than 8. So when we go to write it in the other direction, it's important that we write it as a mirror image of itself, as though we took the whole thing and just swapped it around like a mirror image. Whoops. So let's think about it. Initially we said 10 is greater than or equal to x. So some of the solutions to that would be 9, 8, 7. And so now that we've switched it around, is that relationship still retained? 9, 8, 7, are those less than or equal to 10? Yes, so we've done it properly. So don't confuse this switching of the sign with the situation that we get into when we divide or multiply by a negative number, which we're going to explain in just a minute. Here all we're doing is reversing the sign because we've switched the sides of our inequality, and it's important to understand when we do that. All right, now we've got a number line here that's not working out for us, so I'm going to draw another one, and I'm going to put my own numbers on it, and I'm going to put a 10 there and a 9 and an 11. All right, so go ahead and draw one for yourself as well. Less than or equal to 10 means we have a solid dot at 10 and going over there to the left.